In 2020, the pandemic shattered the global semiconductor supply chain, causing widespread shortages across almost every modern industry. The sudden halt exposed a critical structural vulnerability. The vast majority of the world's technological manufacturing base was hyper-concentrated in a small geographic pocket of East Asia. In response, the United States and its European allies placed a digital padlock on the industry's ultimate choke point. They blocked the sale of the most advanced semiconductor manufacturing equipment to Beijing, deliberately throttling China's military and artificial intelligence capabilities. This aggressive embargo created a massive manufacturing vacuum in the region. The West urgently needed to cultivate a secure, sovereign manufacturing base elsewhere in Asia to balance global technological power. The solution to that vacuum was formalized on May 16, 2026. Inside the walls of Bombay House, India's Tata Electronics signed a Memorandum of Understanding with the Dutch equipment monopoly ASML. This agreement outlined an $11 billion initiative to build India's first commercial semiconductor fabrication plant, engineered specifically to process 300mm silicon wafers. To make the facility operational, Tata assembled a coalition of 3 distinct nodes, creating a strategic triangle that connects the hardware of Western Europe and the blueprints of East Asia to the manufacturing execution of South Asia. This strategic alignment allows Tata to leverage established global expertise to shorten the industrial learning curve that usually defines this sector. The first leg of this triangle begins in Veldhoven, Netherlands, at the headquarters of ASML. They possess an absolute monopoly on the most complex manufacturing hardware on Earth. ASML is the sole producer of extreme ultraviolet, or EUV, lithography machines. No other company possesses the capability to engineer them. This animation illustrates photolithography. A machine projects light through a blueprint, shrinking the pattern through a series of optics to burn a precise grid onto a silicon wafer. ASML's EUV technology uses a 13.5 nanometer wavelength of light, bordering on the X-ray spectrum, to carve physical circuits that are mere atoms wide. A single one of these machines costs upward of $300 million and contains over 100,000 individual parts. Transporting just one complete unit requires the cargo capacity of multiple Boeing 747s. The Memorandum of Understanding dictates that ASML will deliver a holistic suite of these tools to Tata. Even if future global trade restrictions tighten, India physically secures the restricted hardware required to manufacture advanced chips. An EUV machine cannot function without exact operational instructions. The second leg of the triangle secures those blueprints from Taiwan. Tata signed a vital technology transfer agreement with Powerchip Semiconductor Manufacturing Corporation. This provided immediate access to a proven portfolio of chip designs, ranging from 110 down to 28 nanometers. Processing this portfolio on ASML hardware creates an immediate human capital deficit. Standard engineering degrees do not prepare a workforce to manipulate extreme ultraviolet light. To solve this, the ASML deal establishes a direct academic corridor between the two nations, leveraging elite technical institutions like the Eindhoven University of Technology in the Netherlands. These Dutch universities are paired directly with premier domestic hubs, including the Indian Institute of Science in Bangalore, to train a specialized local workforce in lithography-intensive skills. This pipeline imports the decades of tacit, hands-on knowledge required to operate the hardware on the factory floor. Hardware and human capital converge at the final point of the triangle, a greenfield site in Dholera, Gujarat. This location will house a massive fabrication plant, engineered from the ground up to process 300mm silicon wafers. ASML is actively deployed on the ground. Their engineers are working alongside Tata to co-develop research infrastructure and build a localized, proactive supply chain so the fab can operate continuously without waiting for overseas replacement parts. Dholera operates as the physical engine for this strategy, anchoring the transfer of global manufacturing capabilities into a domestic Indian facility. The speed of this development is supported by the India Semiconductor Mission, a state-backed framework designed to construct a full-stack independent chip ecosystem. The Dholera plant only handles the front-end fabrication of the silicon. To complete the production cycle, Tata is simultaneously rushing to build a massive back-end packaging and testing facility in Jagira Road, Assam. Once operational, that secondary facility is projected to output 48 million packaged chips every single day. By controlling both the front-end creation of the chips and the back-end packaging, India can insulate its domestic production from foreign supply chain disruptions. The United States and Europe actively curated this exact alliance. They required a high-capacity manufacturing partner in Asia, and they chose India to fill that role. This map visualizes the new reality of global trade routes. It locks in a direct supply chain corridor between the Netherlands, Taiwan, and India, bypassing mainland China. Significant intellectual property and hardware are now flowing through this established circuit. By negotiating direct access to these controlled systems, India is moving toward the front of a manufacturing race that other nations spent 50 years learning to run. The arrival of these restricted systems marks a pivot in the global supply chain, establishing India as a primary technological counterweight in the region.